Welcome to Chapter 2 in the Scuba Educator's Equipment Service course. Today we'll be discussing cylinder valves. The cylinder valve safely allows high-pressure gas to be removed from the cylinder. The valve can be a simple one-function valve, or it can include a reserve feature. We'll talk more about that later. Valves can also be used to join cylinders together, as in doubles. In gas systems, things try to remain in balance. That is, high pressure will always try to equalize with low pressure. Valves in scuba systems stop gas from flowing or regulate the flow of gas. Where gas pressures are stopped or regulated, there is always a soft component and a hard component. And this principle will be important to the valve and also come up in later classes. There are other places in scuba gas systems where pressure is prevented from leaking, such as the cylinder O-ring. There are also places where engineers try to equalize pressure around a component, or where parts that rotate are allowed to move, but gas pressure is prevented from leaking past. Scuba equipment uses both seals and O-rings, and we will investigate the use of each in the equipment we will be working on. For the scuba cylinder valve, turn the valve on and off gently. Don't use too much force. Turning the valve off with too much force can damage the high-pressure seat. When turning on the valve, open gently all the way and then back just a bit. That way, when someone checks to see if the gas is on all the way, they don't apply too much opening force, which could damage the valve. Once gas is on, breathe from the regulator and watch the high pressure gauge. It should not fluctuate during inhalation. And if it does fluctuate during inhalation, that means the cylinder valve hasn't been opened far enough. So let's get into the history of valves. Originally, in the 1940s and 50s, valves had half-inch tapered threads, and pipe compound or Teflon tape was used to seal the threads, where the thread came into contact with the cylinder itself. Modern valves are mainly 3/4 inch straight threads, 14 threads to the inch, and sealed with a neck O-ring. Officially, 3/4 inch 14 NPSM is the designation for that thread type. In the original Renee's Sporting Goods catalog, valves were listed by letters such as I, J, and K. Item J was a reserve type valve, shown here in the picture. Item K was a non-reserve valve on the right-hand side of the slide, which is why we call the standard valve today a K valve. It was item K in the catalog. And the reserve valve, by default, became the J valve. The reserve valve has been pretty much made obsolete by the submersible pressure gauge, though you will still see them in service. Other curious valves from the past included the tank banger that banged against the cylinder wall when air pressure was low. Valves are made to accommodate yoke and DIN type regulators. DIN uses a captured O-ring and is typically used for pressures in excess of 3,500 psig. Now, in the United States, we don't have cylinders that exceed that pressure, so there's really not a purpose for DIN. And there's no advantage to DIN for pressures that are less than 3,500 psig. There are convertible valves, and in fact many of the valves today on the market are convertible, that can be used for DIN or yoke type regulator. .300 bar DIN valves and cylinders that accept the 300 bar DIN valve typically use a different threading than the standard scuba valve, which is called 7/8 inch -14 UNF. It's a smaller size, and the threads are slightly different to prevent using a 200 bar valve in a 300 bar cylinder. And just a little bit of trivia, I once saw a 300 bar valve that was actually a machined down 200 bar valve, which made the thickness of the metal extremely thin. Very, very dangerous. Not a very smart thing to do. Then these are other types of valves: H valves, Y valves, and gang valves that join two cylinders together to form a set of doubles. They all have their purpose. Much of the valve is made from machined brass. In other words, a solid piece of brass is machined into the shape of the valve, polished and chromed. But remember that brass is a fairly soft metal, and so rough use will damage or destroy the valve. We can see on the left somebody took a pair of pliers or vice grips to turn this valve. That's not acceptable. And on the right, this valve is actually damaged by dropping, probably right on top of it. And if it dropped that hard, it could have sheared the valve off, creating a rocket. So be careful with valves. It's just some terminology for the valve. We know that the opening or orifice is where air is delivered to our regulator. The orifice is surrounded by an orifice O-ring, and that O-ring needs to be checked to make sure that it's in good shape. If you see little bubbles coming out between the yoke and the O-ring or the valve, then you probably have a damaged O-ring. Gas is turned on using the hand wheel, sometimes called the knob. So that's how the valve is opened and closed. On the other side of the hand wheel for the K valve, we have the burst disc assembly. And then the valve is threaded into the cylinder using a threaded neck. There's a neck O-ring which prevents gas from escaping when the valve is threaded into the cylinder. And then the dip tube. The dip tube is really designed so that if you had debris or water and you went upside down, you wouldn't be breathing through that. Now, how many people would like to be diving with water or debris in their cylinders? I don't know. And I think that this is a holdover from the old days when things were a lot more freewheeling. Now, if we take the valve apart, and this is a K valve, so a standard single action valve, which is what most people will be using, we can see that there are internal components, and we're going to be covering all these in great detail when we get to the hands-on part. So it's really not that important to know everything that's in the valve at this point, but you see there are quite a number of components along the valve itself. The valve stem, everything from the hand wheel and the stem nut into the high pressure seat. The high pressure seat is actually a piece of brass or bronze. Sometimes I've seen stainless ones, and there is a molded plastic compound, probably nylon, that's contained inside that seat. So that becomes the soft part of the seat, the soft component. And the hard seat for the valve is actually machined into the body of the valve. So that's where the hard and soft seats come together inside the valve. And we'll get into this in greater detail when we get to hands-on. Maintenance and repair. After use in a pool or ocean, rinse the cylinder valve, including the orifice, and then use cylinder pressure to blow water out of the orifice. Have the valve serviced every 5 years when the cylinder is hydrostatically tested. Be careful with valves. They're made of soft brass. Same picture again, damaged by dropping. But if you damage the face of the valve and it can't make a seal, you got to get a new valve. So please take care of them. A sheared off valve will turn a cylinder into a poorly guided and dangerous rocket. Always secure cylinders during transport. Lay cylinders down when they cannot be monitored. It is acceptable to use the valve to carry a cylinder. Replace the orifice O-ring as needed. If the valve is leaking, find out where the leak's coming from. Stick it in water. See where the bubbles are coming from. Sometimes the cylinder neck O-ring will leak, and that's generally a situation where salt crystals have built up on the O-ring. If you're in an area where it's warm and you're diving in a lot of salt water and the cylinder dries out before you get a chance to rinse it, salt deposits can start to build up on the O-ring. They work their way down the O-ring, and eventually they'll start to cause leaking between the cylinder valve and the cylinder. Now, this is not something you can fix in the field, because what you have to do is you got to let all the air or gas out of the cylinder, remove the valve, and replace the O-ring. And often you also need to clean the surface where the O-ring is seated, which is called the gland. Some people call it the land, but the place where the O-ring seats in the cylinder, between the cylinder and the valve, the salt crystals will get in there too. And here we're talking mainly about aluminum cylinders, because steel cylinders, that surface is tapered and usually doesn't have an issue. But on the aluminum cylinders, if the land or gland has deposits on it, it's not really corroded, but you can clean it up. And this O-ringer tool that most dive shops have it's like, it has a little ring of sandpaper right there, and then the operator simply turns the handle basically and sands the surface to make it nice and smooth. And here's an example of that salt. If you see on the left here, you can see the salt deposit building up. It's really, it's calcium and magnesium salt deposits building up on the valve itself, building up on the O-ring, and also on the surface of the O-ring gland. So that's the place where the O-ring sits in the cylinder neck. Burst disc assembly. If the burst disc assembly is leaking, and it can, but this would be rare, but you might see a few bubbles coming out of the burst disc assembly, very, very carefully try tightening the burst disc. The burst disc is really, it looks like a little bolt, hex head bolt with holes drilled in it. And this is designed to let gas come out so that it will vent this way and that way instead of out straight up to the top of the page, which could potentially knock the cylinder over if there was enough force coming straight out. So they lowered the diameter of the holes and they made them go laterally. So try tightening that with a wrench, but be very, very careful. If you break that off, then you're going to potentially get a rocket, which is not a good thing to be around, because the cylinder weighs about 40 pounds. Gas, cylinder, and valve together, and flying around, it can cause extreme damage and fatally or severely injure people. If the gentle tightening doesn't work, take it to the dive shop. The dive shop knows what to do. Valve stem. The valve stem may be leaking, and there are components, as I showed you before, along the valve stem that are designed to prevent gas from leaking up the stem and past through the handle. Somebody will come in and say, "Oh, the handle's leaking," or "the knob is leaking." The handle's not leaking, the valve stem's leaking, because inside there are generally a Teflon washer, sometimes two Teflon washers. Some of the older ones, there was a Teflon washer and an O-ring. Sometimes there were two O-rings and a Teflon washer. Today, modern ones typically have two Teflon washers. And if they're leaking, then the valve stem needs to be taken apart and serviced. You cannot fix that in the field. But if you had a slight leak, you might try tightening the bonnet nut, which holds the valve stem in place just slightly. Don't over tighten it. And if that doesn't work, take it to the dive shop. To remove the hand wheel requires a special screwdriver, which can be purchased from a company that sells scuba tools, scuba repair tools, or you can take a good quality screwdriver and use a grinder and grind out a gap in the blade of the screwdriver, and that there's actually a split nut that holds the hand wheel in place. Some of the manufacturers these days are using hex nuts, but you'll see quite a number of the split nut design because they've been around for 60 years. To properly service or repair a valve, it needs to be removed from the cylinder. Do not attempt to do this without being under supervision. Do not remove the valve by banging on the hand wheel. Now this is, the gas has to be emptied from the cylinder before anything can be done about taking the valve out of the cylinder. Otherwise, it's very, very, very dangerous. So take the gas out of the valve. Do not remove the valve by banging on the hand wheel with a mallet like they do at Coral Reef. It can and will damage the valve stem and the hand wheel. And if your valve stem is bent, we need a new one. Once the valve is off, the cylinder, we disassemble the valve into its components, and we will be doing this later on in the course so we can see exactly how the valve comes apart and what's inside in terms of internal components. All the metal parts will be cleaned in the ultrasonic cleaner. Some parts need to be replaced. Some can be reused. Again, it's not worth going over that right now for individual parts. It'll make a lot more sense when you see it hands-on. Reassembling a valve requires a torque wrench for the bonnet nut and the burst disc assembly. Anytime you're reassembling soft metal compounds that are like brass, it is absolutely essential that you use a torque wrench for reassembly because it's easy to over tighten things and you can break them. Questions? Contact me. Thank you.